We continue from where we left off. We are dealing with Pat Statsdad, who is not a good student, taking a statistics course, and the strategies used is to rely on luck for the next quiz. So the quiz consists of 10 multiple choice questions. Each question has 5 possible answers, only one of which is correct. She plans to guess the answer to each question. We've shown that this is a binomial experiment. There's a fixed number of trials n equals 10. An answer can be correct or incorrect. The probability of a correct answer is 0.2, and that does not change from question to question, and each answer is independent of the others. So this is a binomial experiment. N equals 10, P of success is 0.2. What is the probability that you get no answers correct? That is, x equals 0. Hence, we want to know the probability that x is equal to 0. P of 0 equals 10 factorial over 0 factorial, 10 minus 0 factorial, 0.2 to the 0, 1 minus 0.2 to the 10 minus 0. We just substituting into the formula, and the result is 0.1074. So Pat has an 11% chance of getting no answers correct using the guessing strategy. What's the probability that she gets 2? 2 answers correct. That is, x equals 2. Hence, we want to know the probability that x is equal to 2. Probability that x is equal to 2, we substitute in the formula accordingly. Given 10 factorial over 2 factorial, 10 minus 2 factorial, 0.2 to the 2, times 1 minus 0.2 to the 10 minus 2, and the result is 0.3020. So she has a 30% chance of getting exactly 2 answers correct if she decides to guess. Cumulative probability. Thus far, we've been using the binomial probability distribution to find probabilities for individual values of x. To answer the question, find the probability that Pat fails the quiz. This requires a cumulative probability, that is, the probability that x is less than or equal to x. If a grade on the quiz is less than 50%, that is, 5 questions out of 10, that's considered a failed quiz. Thus, we want to know what is the probability that x is less than or equal to 4 to answer this question. The probability that x is equal to less than or equal to 4 is equal to the probability x is equal to 0 plus x is equal to probability x is equal to 1 plus the probability that x is equal to 2 plus the probability that x is equal to 3 plus the probability that x is equal to 4. And all these are summed. We already know the probability that x is equal to 0 and x is equal to 2. Using the binomial formula, we've calculated the other probabilities, p of 1, p of 3, p of 4. We have, therefore, that probability that x is less than or equal to 4 equals, adding these gives 0.9672. Thus, it's about 97% probability Pat will fail the test using the luck strategy and guessing at answers. That is, she has a 95% chance of failing the quiz if she guesses. The binomial table. This is an alternative way of calculating the probabilities. Calculating binomial probabilities by hand is, of course, tedious and error-prone. There's an easier way. Refer to Table 1 in the Appendix B. Table 1 in Appendix B will give this table. For the Pat Statsdad example, n is equal to 10. So the first important step is to get a correct table. Getting the correct table where n is equal to 10. That will be shown in Appendix B. The column we're interested in is 0.2, this column. The binomial table, the probabilities listed in the tables are cumulative. this is to be reiterated. The probabilities listed in the tables are cumulative. That is, the probability that x is less than or equal to k. Those are all the probabilities that are given in the tables. The probability that x is less than or equal to a given value, where k is the row index. The columns of the table are organized by the probability of success, that is little p values. Here n is equal to 10, the k values 0, 1 to 9, and the column values are the success. So we're interested in these two columns, the first column and this column where the probability of success is 0.2. So we are interested in these two columns. What is the probability that Pat fails the quiz? That is, what is the probability x is less than or equal to 4? Of course, this is read directly from the table. Given the probability of success is 0.2 and n is equal to 10, we go down to n is equal to 10, so we have the right table. Probability x is less than or equal to 4. This is the row 4, k is equal to 4, and this is the answer here, 0.967, the same column where p of success is 0.2. So the probability x is equal to less than or equal to 4 is equal to 0.967. This is read directly from the table. This is what the table gives, cumulative values. So there is no need to use a formula. You can read it directly from the table, which of course is simpler. The probability x is equal to 0. The probability she gets no answer is correct. X is equal to 0 is the same as x is less than or equal to 0. So this can be read directly from the table as previously. Probability x is equal to 0 or less than or equal to 0 is 0.107 to 3 decimal places. The probability that Pat gets 2 answers correct, that is, what is x probability that x is equal to 2? Notice this is not cumulative. The probability that x is equal to 2. So you can't read this directly from the table. Probability x is equal to 2, given that the probability of success is 0.2 and n is equal to 10, we have to do two things. The probability that x is equal to 2 is equal to the probability that x is less than or equal to 2, which is read from the table, minus the probability that x is less than or equal to 1. Probability that x is less than or equal to 2 is given by, come to the table, k is equal to 2, this is 0.678. The probability that x is less than or equal to 1, following the table, this is 0.376. So the difference is 0.678 minus 0.376 gives you 0.302. The probability, therefore, that she gets exactly 2 right, 2 correct, is 0.302 to 3 decimal places. So to find the probability that x is equal to a particular value, you have to do the subtraction ritual. And we're given the general formula which looks at the general situation. The binomial tables give cumulative probabilities where probability x less than or equal to k. Less than or equal to. What we've seen in the last example, the probability that x is equal to k, pay special attention to this, is equal to the probability that x is less than or equal to k minus the probability that x is less than or equal to k minus 1. Likewise, for probabilities given as the probability that x is greater than or equal to k, we have the probability that x is greater than or equal to k is equal to 1 minus the probability that x is less than or equal to k minus 1. So for example, the probability x is greater than or equal to 5 and over, is 1 minus the probability that x is less than or equal to 4. which is in the example just passed, less than or equal to 967, that gives about a 3% probability of passing. There's yet another method of finding the probability, binomial probability, and this is using the Excel function binomdist. We will open Excel and evoke the function accordingly. And once we brought up the table, we will get, you look up the binomdist, evoke that function, Excel function, and this window comes up. What is the probability that Pat gets 2 answers correct? The number S equals 2, the number of successes. The number of trials is equal to 10. So you insert 10 here. The probability of success is 0.2. So insert the 2 here. Now in this cumulative row here, a window, it asks whether or not you are accumulating. The probability that x is equal to 2 means you're not accumulating. You're looking for a particular value. You're not adding any values, hence you write false. Once you enter false, the result is shown here. The probability that x is equal to 2 is 0.3019819 blah blah blah, or 0.30202 4 decimal places. So this is yet an easier method than even using the tables for finding the probability. You could do the same thing. Probability x is less than or equal to 4. Probability fails the quiz. Here, the number of successes is 4. Number of trials is equal to 10. Put in 10. The probability of success is 0.2. That still remains the same. And you're accumulating, so you put true, because you're finding probability x is less than or equal to 4. You're adding probabilities 0, 1, 2, 3, 4. So you put true for cumulative, and your result is 0.9672 to 4 decimal places. That takes care of the binomial. Note that the mean is given by number of trials times the probability of success. The variance is NP times 1 minus P. Some books have NP 1 minus P, the right is Q, that's NPQ, and the square root of the variance is the square root of NP into 1 minus P. That gives you the standard deviation. The Poisson distribution, named after Simeon Poisson. The Poisson distribution is a discrete probability distribution and refers to the number of events, also known as successes, within a specific time period or region of space, or both. For example, the number of cars arriving at a service station in an hour, the interval of time is an hour. The number of floors in a bolt of cloth, the specific region is bolt of cloth. The number of accidents in one day on a particular stretch of highway. The interval is defined by both time, 1 day, and space, the particular stretch of highway. Poisson experiment. Like a binomial experiment, a Poisson experiment has 4 defining characteristic properties. 1. The number of successes that occur in any interval is independent of the number of successes that occur in any other interval. 2. The probability of a success in any interval, is the same for all equal-sized intervals. 3. The probability of a success is proportional to the size of the interval. And 4. The probability of more than one success